Oskar Stålberg. Oskar, I hope that I'm pronouncing that name correctly.
Hello. Yeah,
Hello.
that's perfectly all right. Yeah.
Okay, we can hear you well now. So the mic is seems that the mic issue is resolved, which I'm happy with.
Yeah, I was on my phone cleaning up the kitchen while I asked the last questions. Yeah.
Okay, fully understand how that works. So yeah, I want to welcome Oskar for this Q&A session. So Oskar is an equal part artist, game designer, programmer, and I would say creative mathematician. And he does all of that without losing any depth in any of those fields, which is truly amazing. So what we will now do is take a peek under the curtain of his beautiful town building tool. I guess it's more of a tool than a game.
Yeah, I usually call it a toy because it's not really a tool either. Kind of. It could have been a tool, but it's more of a toy.
Okay, so Townscaper, and the way that we will do this, I think that I will start off with 20 minutes with questions coming from me, and then we will follow with some questions from the audience. I wrote some questions. I think it would be about 2 hours to cover all of them, so I will need to optimize my own list and see how we are moving through the conversation. So I'll start off with a more of a philosophical question.
Should I just start the thing to just show it off so we have something nice to look at?
Yeah, let's do that.
Yeah. Are you seeing the correct screen? Are you seeing Unity?
Yeah, we can see the screen.
Yeah, perfectly. And let's just launch the game so we have something to look at. Yeah, okay, fire away.
So while we're looking at the game, my first question would be a more of a philosophical one, and I'm curious how much of a vision of the final product you have when you start a project, because I know that you had this you have this precursor to Townscaper called Brick Block, I believe.
Yeah.
That I also think you showed at a museum here in some years ago when you came first time for everything procedural. And the curiosity here is it more of an exploratory journey? You see where you land and where you let the project guide you, or do you have a clear idea of what you want to achieve? Is there someplace a drawing of exactly what Townscaper would look like made like 2-3 years ago?
So, I mean, this varies a lot by project, I would say. Townscaper, I had a fairly clear idea of what I was doing because I had been exploring these kind of environments before, and I really wanted to. So Bad North, which my previous game, which I talked about at the last procedural conference I was at, that one actually started looking like this kind of colorful architecture as well. But then I had to make it into a game, and I couldn't figure out how to make a good game set in that kind of environment. So then I made Bad North instead, because it's always easy to make a good game if you just add some violence to it. But then this time around, I was like, okay, I really want to make these colorful environments now. And I have learned a bunch of new algorithms and approaches as I was making Bad North and as I was making some other things. So this time I'm just going to make a colorful town builder. And I know that people like those kind of things. I don't know if it will sell well, but I know people like them. So I'll just do that this time around, because when you start adding gameplay to things, you need to design your environments to fit that gameplay. And that's a fun and interesting exercise to do, but I wanted to try for once. Okay, but what if I don't have to do that? What if my environment sort of is the gameplay in and of itself? Because normally you need to not necessarily remove the clutter, but you need to tone down the clutter so that the game, and this is a click and what's it called? A click and play, point and click game, because then obviously the clutter is part of the gameplay because you need to find things in the clutter. But normally when you make a game, you need to put the visual attention on the relevant actors in the game, the players, the explosions, the enemies, stuff like that. But I wanted to say, okay, but what if we don't need any of that? I just put all my visual efforts and attention into the just nice little props and a nice little environment, and let's just make that. And so I had with Townscaper, I had a fairly good idea of what I was doing when I started doing it. But with Bad North, for example, I did not. That was a much more exploratory experience.
Okay, that's again very interesting to hear that you are mastering both, right? Because those are two quite different projects and different approaches, and both end up being very successful, beautiful things to look at. I'm still terrible at Bad North, but I try it every once in a while, see if I've gotten any better. And something that we briefly touched upon in the kind of the practice session for this conference was something that you wanted to talk about, was the design implications of procedure games. How are they different from more classical approaches?
Yeah, so let's see if I remember what I wanted to say there. I mean, I think Joris actually covered a lot of the interesting things there, where like you really need to pick a game style that fits a procedural world. Like with Bad North, that was a strategy game. A very spatial games kind of work well usually, like games that are very geometrical, because then you make when you just throw a new environment at the player, and then the shape of the environment decides like what kind of strategies they can use. Whereas if you have a much more like stats-based game, for example, well, if you throw interesting procedural environments at a game that's much more dependent on like what kind of stats your character has, then those environments don't really matter that much. Then of course, like you might do other things like procedural gear or things like that. But there's also you also need to think a lot about what Joris mentioned that as well. What scales your procedural generation works well at, because you can make the error of scale, like doing some nice procedural generation that looks amazing when it's small, but then you scale it up and it starts to look way too repetitive. And yeah, you can sort of address that by making larger and larger patterns that keep the thing interesting as you zoom out or as you keep traversing through the world. Whereas, but that's hard, and it becomes harder and harder the bigger your thing becomes. So when I made the precursor to Townscaper, which doesn't have multiple colors and doesn't have this weird grid that Townscaper had, it's called Brick Block. Then I made the world you could build in much smaller, because if I made it any larger than that, it just started to look like a repetitive voxel world. Whereas in Townscaper, I have like a couple of larger patterns that appear as you keep building larger things. So of course you have the different colors, so you can build like different parts of your town in different colors. But you also have the grid, which sort of creates larger patterns and larger shapes that makes your thing interesting as you zoom out. But even there, like I made a limit to how large you're allowed to build, because when you start building too, well, first of all, of course, there are performance issues when the thing starts to become too large, but also it starts to look too repetitive and it doesn't look interesting enough. Like you would need, for that to still be interesting, you would need some, like probably some huge church domes or stadiums or something like that, like larger scale patterns. And those were kind of hard to fit technically and sort of UX wise within the kind of framework that Townscaper has. Yeah,
that's a very clear answer, and now we can kind of see why unexplored, for example, Joris' game has 2 layers of procedural generation, and one is kind of the world map that he showed in some of those.
Yeah, and that also technically solves a lot of problems, because if you need to generate everything at once, then if something breaks in one side in your procedural generation, then the entire thing breaks and you need to regenerate it. Whereas if you're making a world map and then you're making chunks separately, well, first of all, you don't need to generate everything at once. And also, of course, yeah, it's more like a series of isolated problems that can break in and of themselves. I mean, that's the same with Bad North and generating the levels in Bad North. There's separate levels. If they break, just that one breaks, and then you just regenerate that one. Yeah.
Exactly. You focus on one problem at a time.
Yes.
So you already touched briefly upon the grid, and this toy lives on the grid, and I don't know how much of that is visible, but this grid is actually it's made out of quads. So it's a quadrilateral grid, but it doesn't look like that. It looks very organic. So can you tell us a bit more about
Yeah,
this?
so this is kind of one of the big sort of technical foundations of Townscaper. Like one of the interesting things that I thought, okay, this would be a very fun thing to do. So I'd say the two core technologies of Townscaper is this grid, and then it's the wave function collapse algorithm that I talked about before. And the grid is, it's an irregular quadrilateral grid in that it's all made of quads. So if we zoom in here, we see that all these pieces are quads. They're four-cornered, but they fit together in weird ways. So obviously in a normal grid, a quad, like a corner always has four quads next to it, like this one. But here you occasionally get, like here's a corner with three quads, and here's a corner with six quads. And what that does is it allows, like this was an interesting way to solve the problem of, because when you make especially tile-based procedural things, it's very convenient to use square or hexagonal or triangular pieces because they're uniform, and then you can fit them together in different ways. But of course, this makes the whole thing look a bit repetitive and gridded. But this was a good approach to sort of make more organic shapes, but still use square tiles. So the input to this is just like, here's what the Maya scene looks like, where I build all these little, so they're like handcrafted sort of mostly. So you build these little pieces and you build them square, and then you just kind of distort them to fit the quads. So you can see how, like, if I find a hexagonal or a pentagonal thing here, you'll see how like it bulges in a bit like that, which looks a bit weird and goofy, but I can kind of allow that in this setting. But yeah, so it's an easy way to allow me to use the benefits of square tiles, which are uniform, but still get a sort of organic look out of it, and be able to make these kind of like nice looking European style streetscapes. And then there are like different parts of the grid are, like some are more chaotic than others. So you have some areas like here where there's a fairly big sort of square-ish section. And then there are some areas like maybe over here where it's much more chaotic, and the grid starts sort of, is much more mixed up. And if you can see like out here, you see the grid is sort of divided into hexagonal chunks that are generated one by one. So some of them are set to generate in this sort of more chaotic way, and some are set to generate in a more regular way. And the way they are generated is it's actually made out of triangles, and then the triangles kind of randomly join up to form quads, and then you subdivide everything to become more quads. And then depending on how many triangles, like the resolution you start with, you get more chaotic or more uniform results, basically.
Yeah. Thank you very much. There is actually a video that you can find online where Oskar goes even more details about the grid system. So we will not necessarily spend more time on the grid system, just because there is an overlap with material that's already out there. To briefly sum it up, you start off with a hexagonal space in which you create triangles, and then you merge those triangles, some of those triangles into quads, and those quads are then further subdivided, and the triangles that are not subdivided.
Here I have a GIF
perfect.
Just explaining exactly what's going on. Let's just make that full screen. All right. Yeah. So there we go. This is also a tweet I have. So yeah, you create triangles, and then you randomly join the triangles. And that was sort of when I came up with this thing, that was kind of one of the, like that's when I kind of realized, okay, if I combine this with the kind of wave function collapse stuff, I know that I have something interesting that can become a project in and of itself. Yeah.
So then each one of these quads is unique, right? As in, it has a.
Yes.
How do you identify it? Is there an index to it?
So the chunks, so these ones, the ones that have the white outline, like the hexagonal chunks, they can be referenced directly through a kind of index system. And then within each chunk, you need to go search for the right quad. So like when I want to do, like when you need to find out, for example, where the cursor is, like which chunk you have, or which quad you have the cursor over, then yeah, you like at first you can directly like you do some rounding and then you can directly identify what chunk you're in. But then in the chunk you need to go search for exactly which quad you're in. But that's not too, I mean, but they're ordered left to right, so you, or like according to one axis, so you know what and like where to start searching to, so you don't have to search that long. Yeah, okay. But it's the grid is essentially like an arbitrary grid that's just described like with data, which I mean that's usually how I write my grids, and it works perfectly all right.
Okay, so it knows its neighbors. Each kind of quad there knows its neighbors, and it can, or is that a separate search?
They actually don't know their neighbors. They could have known their neighbor. That would have been a reasonable way of writing it. Or actually, the way it's written is I have the big grid out here is all is written in a very light data structure and all made of structs. So it doesn't. There's no direct references between the things there, and it's all very lightweight. It's all just like a bunch of like a list of vectors and integers. Whereas like when you start building, it creates a much more dense data structure that's much more that's heavier around the things you're building, and there everyone knows about their neighbor and everything's directly referenced and things like that. So it's like the big grid is optimized to not take up that much memory and be generated very quickly, but then as you start building on it, the sort of the graph that appears where you're building is much more optimized for fast generation and like dense interconnectivity, so everything knows about its neighbors and stuff like that.
So when the player clicks to build something at a certain point in space, that basically does a search and then adds something, and it operates directly on the output geometry. It is not stored in some voxel kind of representation in the background from which the algorithm kicks off.
I didn't fully get that question.
So I'm curious, what kind of data structure drives the generation? I know that the wave function collapse needs to know where certain things are, so that we can.
So that part runs on a densely interconnected kind of data structure where like it's actually based on game objects here in. So I have these they're called squares, and then so here's a square. It's not actually a square, it's a quad, but I had already used the word quad for something else. And then the square contains a bunch of cubes, but spelled with a Q because they're in a quad. And then they all know about which neighbors they have. So it's like stacks of these sort of voxels, but voxels means a different thing in this. And they all know that, like this square knows that it next to this square, and the cubes know how they relate to each other as well, depending on where they are in the hierarchy. So this is for the things you build, I do have this properly interconnected data structure. That's exactly, yeah, that's the kind of thing you need to do in wave function collapse, because you need to do a lot of call to your neighbors in wave function collapse. So it's optimized for that, yeah.
And I think that you mentioned at some point that you are using something that you call a mixed initiative wave function collapse, that you are using both marching cubes and wave
Yes.
function collapse. Are the marching cubes like a pre-pass that prunes the space for a wave function collapse? What is
yeah, it's exactly that. Yeah, mixed initiative just means that like it's the kind of procedural generation where the user does some things and the algorithm does some things. And yeah, in this case, it means that the user builds this kind of voxel space. I mean, that's basically the blocks. That's the level of abstraction the user works in. And then I have a sort of marching cubes-like algorithm to figure out, okay, like if you build something like this, then you need a corner up here, or actually you need 4 corners, right? And I have a kind of marching cubes markup of all my different pieces, but there are a lot of different possible corners. So I build the entire possibility space first with all the different corners that would fit there, and then as you and then I do a wave function collapse on it, so you only get one of them. And then the wave function collapse is sort of because I want the results to be kind of predictable, so it's kind of strictly prioritized. So these kind of pointy roofs are highly prioritized, but they need to be like if you just build one story, they can't actually appear because they need like they come in 2 parts. They need this little sort of slimming off bit here. and then they need this bit here. So you need like a larger, so this one can't have that kind of roof, but if you make it slightly higher, you can have that kind of roof. And that's kind of part of the game design part of this as well, sort of designing these kind of patterns through just how I build the different things.
So the tiles are, are very much the rule set for building the world, of course. Exactly, and this is where a lot of the magic sits. And when you mentioned prioritization, that is probably to minimize to localize the problem, that you don't rebuild chunks that don't need to be rebuilt, and that it's kind of stable, that it always roughly builds the same.
Yes, yeah. It does, like technically it usually needs to run the algorithm on basically everything. There's some isolation happening, like if I build something here, it doesn't run here because they're not interconnected. But, and you can kind of see, if I build something, you can see this kind of blinking lines. That's sort of the algorithm sort of traversing the space and doing things. And actually, if I build, if I just build up like this, I don't think, it doesn't have to traverse all the way down as well. But when I added something here, it needs to refresh everything. But yes, so it does refresh everything, but since the prioritization is sort of very deterministic in that way, it doesn't actually change the look of things where you are not building, which is part of that's like, if it was not mixed initiative, that probably wouldn't have been an issue. But now I don't want the user to feel like everything is changing where there's no reason for everything to be changing. So that's why I went with this kind of strict determinism. And actually, how I'm doing the prioritization is actually like, here's the Maya scene where I build everything. So there's like quite a lot of pieces, obviously, and things that are further to the right are higher prioritized, and things that are further to the left are lower prioritized. So most things like these kind of terraces, they're kind of low prioritized, but they fit everywhere. Whereas, for example, the pointy roofs we looked at before, I think, they're kind of high prioritized, but they only, I think, no, this is the lighthouse is even more highly prioritized, but it only fits under some very specific conditions. And sort of, here are the garden pieces. Those are super highly prioritized, but they only fit under very, very specific conditions, like if you make an enclosed garden. So that was kind of an interesting sort of both technical and design challenge to make these kind of things predictable sort of to the users, that they learn, if I build this kind of pattern, this kind of thing will appear. So the gardens, for example, you get them if you build enclosed spaces like this. So if I open this, it will, like, the garden disappears. And if I build again, you'll get the garden back.
Yeah, fantastic. It looks very European. It looks like a lot of, if you fly over the much of Europe low enough, I think this is basically what you will see. Not this cute, not this colorful, but I love it. And one thing that I think maybe it's uniquely yours, and maybe it's easy to underestimate, is that when you add something new to this world, it always animates. So it always goes from one state to another state in a very lovely animated way. And of course, that is probably impossible to do it by hand just because of the amount of work. So my guess is there is some other kind of math and magic that's happening there. Can you guide us tiny bit through that? Yeah.
So there's there is some, I mean, it's some very simple vertex shader displacement happening, where I just record the last place you clicked, and then I just used, and the time you clicked there, and then I just use those as global shader variables, and then I just kind of do a little, nice math to just bounce out the vertices from there. And since the animation is so short, I don't need to keep a list of the latest places you clicked, because like, you can't see if I just interrupt the last animation to play the new animation, basically. I mean, that's usually the case with things that happen this fast, and especially things that are interactive. You usually just care about the last thing that happened. But then also there's just some subtle particle effects with these kind of bricks bouncing around and sort of the dust. But yeah, I mean, that really, adding those kind of little details is super important to get the right feel. Because this is all about, I mean, this is kind of what you would like game dev tools to look like, but obviously it's not practical to have like these kind of particle simulations running when you're sitting in Houdini or whatever, just to be fun when you're editing things. But yeah, it's all part of making everything feel tactile. Just as everything should have sound, everything should have this kind of small animation too.
Yeah, absolutely agree. I also love the small birds. Maybe we can chase some of the birds away from one of the, just to show the attention.
Let's do that. Yeah. And they, of course, use a basic kind of Boyd's algorithm. So you can see them, the red lines that are flashing about is actually them kind of communicating with each other. Because, and we can also look at and they're moved about with a sort of Bézier thing. So I don't need to update all the birds at once. They just need to update every time this little white line is kind of updating. So that's when they played out their, like they need a new position to go to next. And I also have this kind of, because since this game is kind of voxel based, just like with Bad North, I have this kind of voxel space representation that I can, like, so the birds can sample the voxel space to do their object avoidance, which is super helpful. And I also use that, that's probably something I should show off. I also use this kind of voxel space for lighting. So like this kind of very simplified block shape I can use to create my ambient occlusion model. So I'm not actually dependent on the exact look of each house. I'm just dependent on the sort of rough AO. The ambient occlusion, I have this kind of let me see where this kind of mesh that's generated as I build. And you see how it, like, if I just keep building here, we should be able to see, like new little pieces appearing. And it's then baked down to this kind of stacked, like Atlas, AO Atlas thing. And as you're building, it keeps changing in size and layout. And of course, and since it's just a mesh that's being projected onto a render texture, it's very quick to just reproject it. So you can change the dimensions very easily as you edit. And if I build like higher, you'll see how it will add more kind of squares to this, like that. So it's just a slightly blurred version of this, of the voxels. Yeah, exactly. And that becomes kind of a sort of nice looking AO, ambient occlusion, with some slight color bleed to it. If we turn off the textures, we can sort of see it in a bit more detail. So that kind of voxel representation is also, as I said, used for the bird flight. So it's very useful, I find, when doing procedural generations too, especially if you write your own tools rather than using other people's tools. You can usually make use of these kind of intermediate steps. Usually you have intermediate sort of high abstraction level steps, like in this case, it's the voxels, and then I can use those for some things as well. Because they're like usually, they're a cheaper place to do some kinds of algorithms.
And you frequently visualize your intermediate steps, and I think that's maybe also a unique part of your workflow, that you make sure that at every step of the generation, the scene is valid enough to be rendered and shown.
And I mean so there are two things there. First of all, it's very helpful to just visualize everything as you go, just so you know what you're up to when you're building things, because usually you find bugs or you get new ideas when you visualize your things as they're running. But also here, since this is an interactive thing, and like once you start building very, very large things, it will be quite slow for the entire thing to generate. And then but the player should be able to interact with it at all times, even when it's not done generating. So now I'm loading quite a large thing. And you will see like how actually generating the grid is one of the slower aspects, because the relax algorithm is quite slow because it's a very iterative process. But you can see how it's generating a thing, and then the algorithm is running, and it's kind of filling it up from one place to the other. So now the game's allowed to show it, but it's not done generating. It's still filling it up with things, because that takes a while to fill this with windows and with plants and everything. But then I can still keep editing it anyway, and you'll get new pieces, but they won't like resolve immediately. So it was important to just show like a good guess of what a thing would look like when generated. So you get these kind of roof shapes, but they don't fit together perfectly. And then the algorithm resolves those, and then it gets back to adding windows as it was doing before. So now I was allowed to build this part even when it hadn't finished generating this part. And that was just making this kind of, that was a big sort of technical, and it's been a technical challenge throughout this to be able, like all the algorithms need to, the user change something basically.
Yeah. Similar to MIP maps loading in big games when you play. This is like the procedural generation version of streaming stuff in the background. Okay.
Exactly. Yeah.
I'm pretty sure I've run out of time to ask my questions, so I would like to ask the audience now to raise their hands and ask a couple of questions themselves.
All right. Now you can see like the old thing being deconstructed and then a new thing being constructed as I load a new thing. I do a lot of pooling, so the deconstruction needs to be quite sort of careful. I can't just delete what I had because then it needs to go back into the pool as clean data.
Hello, can you hear me?
I can hear you. Yeah.
There we go. There we go. Yeah. You talked like you quickly glanced like over the in wave function collapse the conditions of a tile. Now I've made like a few different games using wave function collapse itself. How do you like either tool it or how do you visualize for yourself the condition, the setting the conditions of a single tile?
Yeah. So it's all. I have a big. This is also how I worked in Bad North. I have a big, so when I build things in Maya, I just build them as a, like without any regards for hierarchy or naming conventions or anything. I do use different materials with different colors as information that I'll use later. But then I have a big import script. We're not going to run it now because by now it actually takes like a few minutes to run. But I have a big import script that analyzes all the different pieces. And then it also actually constructs some. So here you have my scene, and it's not super really, yeah, it's all black. That's not great. But this is the same, like all the pieces that you saw in Maya, but in Unity. And it also generates like combinations of pieces, because obviously you can have a corner opposite another corner kind of when they can fit together and they don't. Yeah. And then if I select one of these, you should be able to see how, like I selected this one and it lit up, and all the edges that fit with that one also lights up, right? So if I select this like an inner corner, then you see all other, it's got like a corner, yeah, like a couple of different types of corners, and all the other ones that fit with that one then lights up. So obviously if you build a new piece, you usually have to go through to make sure it actually does fit with the things that you thought that it should fit with. Does that answer your question?
Yeah, definitely. Thank you.
Yeah, and then I also go through these, of course, to make sure that like it does some analytics to understand that what, you know, which of these corners are inside and which are outside, and which things can have, because a sort of twist on the marching cubes is that it's important what colors different things have. So here's like a wall tile that that can have 3 different colors. So my import script also goes through it to analyze like what kind of color configurations could this particular little tile have. Yeah.
Yeah, thank you.
I think we can do one more question, and for the rest, please ask the question in the Q&A section, and I think that Oskar, if he has time, he will answer them there in writing.
Hi, can you hear me?
Yeah, can you hear me all right?
I first stumbled upon Townscaper on Twitter and I was completely mesmerized by your grid generation. And it made me think of a couple of problems that traditional grids have. Like, for example, if you take XCOM, where you have a square grid, the whole art style of the game is obviously dictated by the fact that it's a square grid, and it constrains the buildings, it constrains how they can angle, it makes the environments a bit boring in my opinion. And you of course have the complete opposite, like your grid is it's flowing, but you lean heavily on the procedural generation side as so the player can build structures, but only also on the grid. Do you think it would be possible to have a hybrid approach where for example, a designer designs an environment that doesn't conform to a grid and you actually generate a grid that conforms to that geometry?
Yeah, for sure, you could do that. It's not I mean, depending on what you need from your grid, it's not even necessarily that hard. I mean, you can just, you know, spawn a bunch of points on a nav mesh generated from that, and then just space them out, and then just, you know, when they have the right density, you use them as a grid. I mean, it would be a kind of Voronoi-like grid, but yeah, you could do things like that. Yeah, I've thought a lot about different types of grids and what kind of implications they have. I like this, and it fits Townscaper very well, but obviously it does have, like, you know, this kind of hexagonal house. That's a bit weird for most kind of other applications. So I've been thinking a lot about if you could do a sort of slightly less goofy version of this that avoids some of the issues. Yeah, or maybe you could do different, like some parts of the grid that could be more like this, and some parts that could be more square. So maybe the architectural bits can be mostly square-ish, but then you can have some environmental bits that are more wonky. And then, yeah, it's going to be hard with this kind of mixed initiative approach, but with some kind of generated approach, it might not be very hard. I know that Joris in his Unexplored does some clever things with like shifting the grid between more environmental areas and more architectural areas.
Okay, thank you very much.
Fantastic. That was lovely. I think that we covered a lot of ground with Oskar. And as I mentioned in the beginning, there is already some material. So there is already a couple of talks that Oskar has made that are online available. And I hope that this one, maybe even together with those, is things that will help you shape like a clearer picture about how everything works under the hood. Oskar, thank you very much for sharing this.
Yeah, it was fun.
And we can hear that it's already in the background, that it's already busy for you. Yes. So give Oskar some time with the Q&A questions. So please be patient with that. We have another mini break coming. So